Welcome back to my channel. You have already learned some programming basics regarding reading data from keyboard and putting them on screen. Today I present some bonus content. Perhaps you are curious how to perform same operations in different languages. So this time I prepared a quick presentation of C. I personally believe that even though while learning one's first language, one should focus on it, the earlier a person gets some basic idea of other languages, the better. In this lesson, we will learn the basic structure of C program and the input and output operations. We will also declare and use variables. It is crucial to understand the difference between interpreted languages like Python and compiled languages like C. There are two major types of program code. First comes the source code, which is normally written by programmers using text editors and can be understood by humans. But computer hardware does not understand programming languages, and it has its own set of instructions encoded as binary numbers. In order to execute a program written in our favorite language, we must run an interpreter that will read our program, and it will act according to the instructions inside it. Alternatively, we may transform the source program into machine code by running a compiler. When the executable binary program is ready, we may run it. Of course, the interpreter and the compiler must already be compiled binary programs. Without them, we would have to code using the machine language directly. That would be very difficult and time-consuming, especially if we wrote programs for modern, complex, and rich CPU architectures. It is important to note that the compiled programs are usually many times faster than interpreted ones. Moreover, compiled executable binaries may be run on a user machine that does not have any source code and no compiler or interpreter installed. The only thing that must be provided to the user is the machine code. Still, compiled languages have some disadvantages. When you use interpretable languages instead, you operate on a higher level of abstraction, and because of that, as a programmer, you may ignore many technical details while using them. Thus, both learning and development process is usually slower when using a compiled programming language than in case of interpreted ones, such as Python. Here you will find some examples of interpreted and compiled languages. Please note that the languages on the left are also called scripting languages, and programs written using those languages may be called scripts. From now on, I will often use the term Python script when referring to a program written in Python. Back to C language. It is crucial to understand that C is a compiled language. Having written the code, we will run GCC compiler to create the binary executable program. Our program will have 10 to 100 times faster execution time than similar Python script. When it comes to the language itself, there are some key differences that you should note. In Python, we only initialize variables by assigning values to them for the first time, while in C, we need to declare the variable along with its type before we may use it. In Python, the type of the variable changes when you assign a value of different type. For example, a variable could be initialized as a floating point number, say 2.5. In C, if a variable has a particular type, only values of that type can be assigned to it. In some cases, automatic type conversions may occur. For example, you may assign an integer value to a float, but the value will be converted and stored in form of a float, not as an integer. The last difference is that in Python, we may just type some commands and the interpreter will execute them, but C program must have a specific form, which we will shortly see. Now, we want to write a small program in C that will display some text, receive numerical input from keyboard, make some calculations, etc. Let's start with Hello World. In C language, we put some text inside double quotes, just like in Python. When we want the program to print the text, we do not use print function. Instead, C language has several different input and output instructions. We will cover just a few of them in this lesson. The first instruction is printf. Instead of just showing text provided as the first argument, this instruction formats a template and inserts information taken from other arguments inside the text. Still, we may use it in a similar way as print function from Python. Please note that we have to finish each instruction with a semicolon. In C language, we cannot simply write a few instructions. The compiler will return an error and complain about lack of main function. We have to define function main and put the instructions in the body of that function. Please do not get intimidated by the terminology we use. The body is simply the place where all the instructions are listed. It starts and ends with a curly brace. Now, the program has a correct form, but it is not complete yet. The function printf is inside a standard C library called stdio. If we want to make this command available in our program, we need to include the C header file stdio.h. Please remember about the hashtag, also called hyphen or sharp, at the beginning of the include instruction. Now we may try to compile and then run this program. I will use gcc.gnu-c compiler to create an executable binary file based on the source code I have just written. Let's go to the console and first list the files. Now I run the gcc command. I specify program.c as the input file and program as the output binary executable. I also add option ANSI so that gcc treats the source code as written according to ANSI standard. After the compilation, I can run the program. The program has printed the text as expected, but I would like it to break the line. I will add a special symbol \n at the end of the string and recompile the program. When I run the program again, I see that it is now perfect. Printf is not the only way in C to show text on the terminal. We may also use the function putAs, which despite its name is more similar to print in Python than printf. Please do not forget that printf means print formatted text, so it does a more complex job than just showing given string value. On the other hand, putAs function will simply show the text and then it will break the line automatically. Let's test what output is produced by the program. The new version of the program prints 2 lines of text just as expected. Now, instead of putAs, we can also use function fputAs, which is dedicated to writing text to files. It takes 2 arguments, the text to write and the file descriptor. In C, standard input and standard output are also treated as files, so we may specify stdout as the output file, thus print the text using fputAs instruction. The only problem is that this instruction will not break the line automatically, as putAs did, which is quite surprising. Again, we have to add the \n at the end of the string. Let's test the program again. Great, we got the same result again. Now, you know the most important output functions of the C language, but how do we work with variables? While creating C programs, unlike Python, we must declare variables before we may use them. It is a good practice to assign initial values to avoid any unexpected results. You may assign the value directly after the declaration, or even in the same line in which you declare the variable. Please note that if you declare a as an integer using keyword int inside the body of the function main, then this variable will stay an integer till the end of the program. For example, a string value could not be assigned to a. We say that C is a statically typed language. On the other hand, in Python, you could change the type of variables anytime by assigning a value of different type. This is because Python is dynamically typed. Now, I will show you a more sophisticated usage of printf function. This time, we will provide a string template as the first argument and our newly declared and pre-assigned variable as the second one. The sign %d stands for a decimal number. It will be replaced by the integer value of a. By the way, please never forget about semicolon at the end of each instruction, otherwise the compiler will complain about it. The program may be recompiled and tested. Okay, as usually, I have forgotten about \n at the end of the string. When the line breaks after the text is printed, the output looks much better. So you know already how to show numeric values using function printf. What about reading numerical input from keyboard? First, let me change the initialization of the variable a to 0. In C, we may use the function scanf to read data of different types from keyboard. The type of the data is determined by the symbol in the first argument provided as string template, and the second argument is called a reference to a variable. It is the name of the variable in which the data will be written preceded by the ampersand sign. Whenever any function is supposed to modify the value of a variable given as an argument, the function should provide the variable as reference using ampersand as shown in the video. If you do not use ampersand, you only pass the value of the variable, so the variable itself cannot be modified. At even lower level of programming, reference to a variable is simply the address in memory where the data should be changed. I know that references may be a little bit confusing. This is one of the reasons why people prefer to write code in Python than in C. Python is easier to understand than C, and that is what I'm trying to show you. Now, I also modified my program so that it adds number 10 and display the outcome of the addition. We are ready to test the program. The source code failed to compile simply because I had invoked the function fscanf instead of scanf. I need to correct my program and try again. I refresh the terminal to initialize the compilation. The source code gets processed successfully, and I can test the program again. I try 3 different values. Way to go! You know already how to display text and numbers, and also you can read numbers from keyboard. How about string values? Can we read them? How do we store them in the memory? is there a string type in C? First, we will use the function fgetS to read the data from standard input instead of a regular file. The third argument, stdin, is the file descriptor that refers to the standard input, so for example, the text typed on the keyboard. The first argument is the variable representing the text buffer. We are also required to specify the maximal number of characters read by the function fgetS. This is very important to make sure the operation is memory safe. The C language does not have a predefined string type. There is only a type called char, which represents a single character, but we also have a special syntax that allows us to define a variable representing multiple consecutive characters. This is called an array definition. So we will store our text in a buffer, defined as an array of characters as shown on the video. We enter the size of the array in the square brackets. This way, we inform the compiler how much memory needs to be reserved for this variable. I compiled the program, but then I realized that I also wanted the program to print back the text provided by the user. I add a printf instruction. Next, I change my mind about the text buffer. In general, names of variables should be as meaningful as possible and connected to their function in the program. This makes the program easier to understand. Oh, and I also forgot to change the variable name passed as argument to fgetS function. Okay, time to recompile and test. You see that writing a simple program that reads and writes text and numbers and makes some basic calculations is of course possible in C, yet we need to keep certain structure of the program and define variables before we use them. We also have to include the library header file to be able to use input-output operations. There are many different instructions to remember for different tasks. Roughly speaking, the code is longer than it would be in Python, and it seems to be more difficult to understand. Now you know better why we say that Python is an easy language. I hope you have enjoyed watching this video. If so, I encourage you to hit the like button and subscribe. See you next time.